Good day to all of you. Today we shall discuss on model question paper Set-2 of the subject Digital Design and Computer Organization with the subject code BCS302. In that question number 2a, write a program in Verilog to demonstrate the working of user-defined primitive table. 6 marks. User-defined primitives can be defined to model combinational or sequential logic. All UDPs, user-defined primitives, have exactly one output that can be either 0, 1 or X and never Z. Z means here high impedance state, that is open circuit. The output is never defined as Z, but it can be either 0, 1 or X. The output can be 0, 1 or X means don't care condition, right? So UDPs can be written at the same level as module definitions but never between module and end module. So we write programs in Verilog using module and end module reserved words. So between module and end module we write the program statements or instructions. Module is the start of program, end module is end of program. But these are not used. Their primitive and end primitive will be used. And in Verilog module, we have to write another program called test bench to give set of inputs to the first program. But here, what primitive, user-defined primitives we write, they will be independent programs. They don't need any test bench. In user-defined primitive table only, we give the set of inputs needed for checking the program. Hardware behavior is defined as a primitive state table which lists out different possible combinations of inputs and their corresponding output within table and end table. Values of input and output signals are indicated using the symbols. So in user-defined primitives, we write set of inputs and outputs, the relation between them, between table and end table that implements the logic function or logic circuit, and that only defines set of inputs for the implemented circuit. No separate module like test bench is needed. So this is the example for user defined primitive. Here output should always be the first signal in the port list. So between primitive and end primitive we write user defined primitive. So here the name of this primitive or program is MUX. Relevant name we have to give. Any name can be given because we are going to implement 2:1 mux. We have given MUX here. In bracket set of inputs and outputs, but as per this instruction always first output signal only we have to mention in the port list. This is port list. SEL, A, B are the inputs, F is the output. So within bracket then semicolon. So this start of primitive is this statement. So inside output F semicolon, this declares F as output, input SEL comma A comma B semicolon. So this declares SEL, A and B as input signals. Next between table and end table we'll have to write the implementation of the logic circuit in the form of inputs and output and with the relation between them. So this is comment line just to show what are these. We have written here SEL, A, B and F column. There are 4 columns. So when SEL signal is 0, if A input is 1, whatever B value of B input, F will be 1. So same as A. So that is what is the behavior of 2:1 mux we are implementing in the form of relation between inputs and outputs between table and end table. So this logic symbol of 2:1 mux, if you take, it has 2 inputs AB, F 1 output, select line 1 more input. If SEL select line is 0, A is selected, F will be whatever A is, irrespective of B, whatever be the value of B, that is what is this. Here whatever be the value of A, when SEL is 1, B is selected, whatever be the value of A, F will be B. So that is the behavior of 2:1 mux. So that is given in the table here. So when SEL is 0, whatever be the value of B, if A is 1, F is 1, if A is 0, F is 0. If SEL value is 1, whatever be the value of A, so if B is 0, F is 0, if B is 1, F is 1. Here 2 extra lines they have taken for implementation. So here cross mark means don't care condition, whatever be the value of SEL. If AB both are 0, output is made to be 0. If AB both are 1, the output is made to be 1. So this is what is one example for user defined primitive. How instead of using module, end module, self-contained program, this doesn't need any other test bench to give the inputs. With the relation between inputs and outputs, the logic circuit is implemented here between table and end table. Okay. So this is what is user defined primitive table. So with an example for implementation of combinational circuit, that is mux, which is 2:1 mux, we have explained user defined primitive table, what it is and how it works. Okay. Next question number 2b, realize F equal to A and B logically ORed with C and D, or we can read it as F equal to AB plus CD using NAND gates only. This carries 6 marks. Solution, given function is F equal to AB plus CD. It is in SOP, sum of products form. So this Boolean function we have to implement using NAND gates only. So the steps to realize the given Boolean function using NAND gates only are as follows. The first one, draw AND OR circuit. Second one, in the middle layer put bubbles. Third one, replace bubbled input OR gate with NAND gate. So F equal to AB plus CD is drawn using AND OR circuit. A, B are the inputs, when ANDed AB comes here. CD inputs, when ANDed CD comes here. A and B here, C and D here. Both are logically ORed. Hence at the output we have here F equal to A and B logically ORed with C and D. Okay. So this in the second step we have to put bubbles in the middle layer. So in all lines here 2 bubbles here also. So 2 bubbles in the sense 2 NOT gates in series. So when 2 NOT gates in series they are connected, it is as though there is no change. Hence this and this will be equivalent. There is no change in the functionality. Just for manipulation of circuit we have taken this way. So in the third step, these 2 NOT gates, when we take here, this is NAND gate. When take up here, this is NAND gate that we draw here. But bubbled input OR gate is equivalent to NAND gate. Hence this is replaced by NAND gate. So this is what is the solution, final solution. That is, the given function is F equal to AB plus CD. It is implemented using only NAND gates, right? That is what is the solution. Next question number 2c, simplify the following Boolean expression using kmap. Carries 8 marks. F of ABCD equal to sigma m of 0, 1, 3, 7, 8, 9, 10, 13, 15. F of WXYZ is equal to sigma m of 0, 1, 2, 4, 5, 6, 7, 10, 15. So here if you observe, this is function of ABCD, this is function of WXYZ. Means 2 expressions are given. These are 2 SOP, sum of products. These are min terms, means products. This shows sum. So sum of min terms means it is sum of products form of expression. There are 2 expressions. We have to simplify using kmap. Okay. So we shall take up first one. F of ABCD equal to sigma m of 0, 1, 3, 7, 8, 9, 10, 13, 15. So here if we observe, the input variables are 4. So 2 raised to 4 equal to 16, hence 16 squares are drawn here. 1, 2, 3, 4, 4 4s are 16 squares. Next, out of 4 inputs A, B, C, D, A, B are written here, C, D are written here. Then 4 combinations for 2 inputs for A, B, 0, 0, 0, 1, 1, 0, 1, 1 are written here. For C, D, 0, 0, 0, 1, 1, 0, 1, 1 are written here. Okay. So after drawing this bin terms places in kmap, we have to fill 1. So 0 is there, 1. 1 is there, 1. But 2 is not there. Min term 3 is there, 1. 4 is not there, 5, 6 are not there, 7 is there. So 1. 8, 9, 8, 9, 10. They are there, hence in those places 1. So 11 is not there, 12 is not there, this 13 is here, there 1, 14 is not there, so 15 is there, we have filled 1. So now after filling, we have to cover these logic ones by grouping them with minimum number of groups. So these two can be grouped with this as quad. Okay. So how on this line, if you take a fold, these two fall on this. Again on this line, if you take a fold, all come in one square. Hence these 4 form one quad. So that is first group. And to cover this is paired with this. Okay, that is second group. Next, to cover this, these two are paired. That is third group. Then this one is remaining. So to cover this is considered both are made as pair because they are adjacent. How on this line, if you take a fold, this falls on this, hence these two come in one square. They are adjacent with each other. These two form one pair, that is fourth group. So after grouping, for every group, row wise what is common, column wise what is common, we have to write. So for first group, in first group these 4 members are there. They are covered in these 2 rows, 0, 0, 1, 0. This second 0 with respect to B is common, hence it is B dash. Next, these 4 members, they are covered in these 2 columns, 0, 0, 0, 1. This first 0 is correspond to C, that is C dash. That is common, column wise. Hence B dash, C dash for first group. Row wise B dash is common, column wise C dash is common in the first group. Then for second group, these 2 members, they are covered in these 2 rows, 0, 0, 0, 1. This first 0 with respect to A, hence we write A dash. Then these 2 members, column wise, they fall in this column, this 1, 1 corresponding to CD, hence CD. So row wise A dash, column wise CD, hence A dash CD for second group. Next, in the third group, that is a pair, these 2 members are in this row. These 2 ones with respect to AB, they are common, hence AB, row wise it is. And these 2 members are covered in these 2 columns, 0, 1, 1, 1. This second one which corresponds to D, hence D. AB is row wise common, D is column wise common in group 3, hence ABD. Next, for group 4, these 2 members, they are covered in this row, hence 1, 0 with respect to AB, AB dash. And these 2 are covered in column wise in these 2 columns, 0, 0, 1, 0. This second 0 is common with respect to D, that is D dash. Hence AB dash row wise, D dash column wise, AB dash, D dash, that is for fourth group. So these terms form the final expression. Hence simplified Boolean expression is f of ABCD equal to B dash C dash plus A dash CD plus ABD plus AB dash D dash. Okay. So next we shall move on to second problem in this. So this is the second problem in this question. F of WXYZ equal to sigma M of 0, 1, 2, 4, 5, 6, 7, 10, 15. Here because 4 variables, 2 raised to 4, 16 squares are drawn. Then W, X, Y, Z are the input variables. WX are written here, YZ are written here. There are 4 combinations of input. For WX, 0, 0, 0, 1, 1, 0, 1, 1 are written here. For YZ, 0, 0, 0, 1, 1, 0, 1, 1 are written here. Next, whichever minterms are there in their places, 1 is filled. This is minterm 0 place. Minterm 1 place 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 places. So now minterm 0, 1, 2, 0, 1, 2, they are present, hence in those places 1. 3 is not there, leave it. 4, 5, 6, 7. 4, 5, 6, 7 are there, hence there 1 is filled. Then 8, 9 is not there, 10 is there, that is filled with 1. 11 is not there, 12, 13, 14, but 15 is there, that is filled with 1. K-map filling is over. Next we have to group logic ones with minimum number of groups here, so as to cover them. So these 4 ones are realized as quad. Then these 4 are covered. Next to cover these 2, with the help of these 2, one more quad is made. Then to cover this is one pair is made. Then these 2 are remaining. To cover them, one pair is made. Okay. So this is group 1, this is group 2, and this is group 3, and this is group 4. Totally 4 groups are realized. So for first group, these 4 members, they are covered in these 2 rows, 0, 0, 0, 1, this first 0 which corresponds to W, hence W dash is common. Then these 4 members, they are covered in these 2 columns, 0, 0, 0, 1, this first 0 which corresponds to Y, that is common, hence Y dash. So W dash Y dash for first group we have written. Then for second group, these 2 if you consider, they are covered in these 2 rows, 0, 0, 1, 0. The second 0 is common with respect to X, hence X dash. These 2 ones, they are covered in this column. So column wise 1, 0 is common with respect to YZ. So YZ dash, hence X dash, YZ dash is for group 2. So next group 3, these 4 members, they come in this row only. So row wise 0, 1 is common with respect to WX, hence W dash X. So these 4 are covered in 4 columns here. Here 0, 0, 0, 1, 1, 1, 1, 0, column wise nothing is common, leave that. Hence WX for third group. Then for fourth group, this pair, these 2 members are covered in these 2 rows, 0, 1, 1, 1. The second one is there for X. Hence for fourth group we are writing X, that is row wise. Then these 2 members fall in this single column. So column wise 1, 1 with respect to YZ. So YZ is written. X, YZ for fourth group. X is common row wise, YZ is common column wise. Now using these terms, so simplified expression is f of WXYZ is equal to W dash Y dash plus X dash YZ dash plus W dash X plus XYZ. Okay. So that is the completion of question number 2C. With this we come to the end of question number 2ABC, asked for total of 20 marks. I hope you understood. Thank you.